Hello. Thanks for having me. It's my first all virtual conference, so I'm really excited. I really like that I don't have to like eat my lunch on a standing desk somewhere. So, but can it have on a proper like desk? So that's cool. My name is Anton, and I'm from working at Sentry as a senior software engineer. And I want to talk to you today about finding and fixing N+1 problems. And basically, I will describe what N+1 problems are, how you can detect them, and then how you can fix them. So after this talk, N+1 problems should not be big problems for you anymore. But first, just a tiny shout out to my colleague Shanna. She was the one that submitted this talk and then also got accepted, but she unfortunately cannot be here this week. So I'm just filling in, and I hope I'm good enough for it. So hi, Shanna. Okay, so N+1 problems. Oh, 1 second. The clicker didn't work. So N+1 problems. If you're a web developer like I am, I did a lot of the work I do is like rendering lists of information and also display related information in those lists. So in my career, I wrote websites that list cars and their dealerships, or bike routes and where this bike route is, the region, or like ads and who created the ads, stuff like this. So basically a lot of time in my life, I spent rendering lists. And because we save our data in databases, and those databases are mostly relational databases, we save it in different tables. So you have your bike routes in one table and the regions in another table. And if you then render this list, it's very easy to create an N+1 problem. And because also like one of the things it is so easy to create those problems is because we all use ORMs, like object-relational mappings. That's basically a layer on top of SQL. So we do not have to write the SQL on our own. So we have something that makes it easier for us to write safe and performant queries to our database. So, but what are now N+1 problems? So let me explain it to you in an example. Here we have a Django model that defines movies and persons. So we will render a list of movies and their directors. Normally, this kind of example is with books and authors, but author is a very hard word to spell correctly for me. So I went for movies and directors. And as I said, we use ORMs. In the whole Python world, there are two big ORMs. One is the Django one you see here, and the other one is SQL Alchemy, which is basically, Django is used by a lot of people because it's there since Django is there, and Django is used by a lot of people. And SQL Alchemy is used by all the other persons. So that's the standalone version of an ORM that you can hook into Fast API and Flask and whatever you have. So, but now our example in Django. So this is how we define our data and how it is stored in the database. So we have a movie and a person table. And the director field is a relationship to from the movie to the person. If we want now to render our list of movies and directors, we normally do it like this. Here on line 10, you see the query where we just select all the movies in our database. Let's assume we have 10 movies in our database. With this line, we tell the database, give me all the movies. And we load it in memory. Then we have our for loop where we go through all the movies. And for each movie, we first print the title, and then we print the director's name. And there is already the N+1 problem. Because first, we do here an SQL query to the database. We create a connection to the database, get data. So far, so good. Then in the for loop, we print the movie title. That's OK, because the title we already have in memory. And then afterwards, we try to print the movie director name. And on this line, Django will say, I do not have the director's name. I need to fetch it from the database. And then it will create here another SQL query to the database. And if we have 10 movies in our database, this will result in 11 queries to the database, which might not sound so many, but it adds some load to the database. So that's the N+1 problem. First, you fetch 10 movies from the database, so our N is 10. And then for each of those 10 movies we do one query for the director. So the first thing is the one query, and below here are the N queries. And that's your N+1 problem. I don't know, don't ask me why it's not 1 plus N problem. It's probably something with marketing, or I don't know. And the same thing in SQL Alchemy, the other big ORM there is, it is exactly the same thing. We have, again, two models, the person and the movie. And the movie has, again, the director that's a relationship to the person. Looks the same, also like the querying and the rendering of our list is basically the same. Those two lines, 12 and 13, are just setting up the connection to the database. But then below, it's the same as in Django. You first say, give me all the movies, then we print the title and the director's name. And you might already guessed it. It's again a 1 plus N problem, because here and here are the queries to the database. So how do we fix this? We have seen now it's very easy if you're using an ORM to create those kind of problems. And fortunately, it is also as easy to fix those problems. In Django, you just have to change a little bit in your query, and you have to tell the query what related fields also to fetch in one go. So there's this select related field you can add and tell them, okay, if you create the movies, please also include the director field. And with this, on the first query, all the information that is needed is loaded in memory. And when we then print the movie and the movie title and the directory name, it's just everything already in memory. So we have one query instead of 11. In SQL Alchemy, the fix is a little bit different. You do not have to change the query, but you have to change how the model is set up. So here we have, again, our movie model with the director field. That's a relationship to the person. And in here, we can set lazy to joined. And what this just tells SQL Alchemy is, if someone is querying the movie model, also include the table that is linked to the director field. And down below, you see the query and the printing is all the same as before, which is kind of nice because, or like nice and not so nice, because in this way, you can fix with like one change in the database. You just change the model, you fix all the queries in your code base. In the Django way, you have to go to all the queries and one by one add the select related field to fix the problem, which also can be here in SQL Alchemy. It's not all good. It can also be counterproductive, because if you have maybe some queries where you do not want to join the director. So fixing the N+1 problem is easy. Also implementing or like getting it into your code is very easy with an ORM. So the hard part is probably to detect N+1 problems. Sorry. If you're working on a very huge or like an old code base where like for the last 7 years, countless developers added feature after feature after feature, it's like a huge code base, which is basically a black box for you. So how do we find all our N+1 problems in there to make our site really fast and safe? There are different approaches where how you can detect N+1 problems in your code base. And the first one is not at all. It's not a very like a hard problem. It's kind of a soft problem. If your site is still fast and your database has no problem with the load, it's like everything is fine, basically. You do not have to fix N+1 problems. You just can live with them and ignore them. So that's the first approach. That's the easiest approach, basically. The second approach is using Django Debug Toolbar. Django Debug Toolbar is a very cool project. It's something you install into your Django projects, and I do it in all my projects I start. It's one of the first things I install, and if you have installed it and you add it to your installed apps and stuff, then when you render your website, you get a little button on the website where you can open this pane, where you get all the information about the stuff that was happening behind the curtains when you rendered this view. And also you can see all the SQL queries that were made while rendering this request. So here you see again N+1 problem as it is shown you in Django Debug Toolbar. The pros and cons in Django Debug Toolbar. Pros is like it's very mature project. It's had been here forever, and it's still actively maintained. It works great. It also works with all databases, so it doesn't matter if you have Postgres or MySQL or SQLite. It has you covered. And also it gives you detailed information, so you see the full query you send to the database, and also the stack trace, so exactly where in my code this query is sent. So this helps if you have like similar queries all over the place. You get pointed exactly to the right location in your code. And it's just great for development to like fix those things early on before they even touch production. The cons is it's only working for Django, so all the fast API and Flask guys are out of luck. And it's also not for production because you do not want to have this debug toolbar button to be seen by anyone visiting your website. And it also works for HTML views, which kind of is, because it's so old, that's the heritage basically. But nowadays, every website is basically an API and some front-end framework. But it also, like, if you use Django with the Django REST framework, the Django REST framework has a browsable API where you can go to every of your API endpoints and you get a HTML response. And Django Debug Toolbar works with this, so you can use it also with Django REST framework. But also the main con is it's a manual approach. You have to go to all your views and render them, and then open Django Debug Toolbar and see what queries were there. Is there a problem? This is also like, if you have it on your local development, make sure that you have not only like 2 movies in your test database, because then this will not work at all. The best thing would be to have like a dump of the live database that you have anonymized, because if you do not, you will basically go to hell, probably, according to GDPR. You have like production-like data on your local machine, so you can see all the queries that are done. The next approach is something called N+1. It is also a Python package that you install into your project and add to your project. It has a little bit a different approach, so it is similar to Django Debug Toolbar as you install it, and while you're running your website, it is doing something. And this N+1, it creates log messages. So if you render your views, and if N+1 encounters some strange queries, it will put out log messages. This is an approach I really like because it's kind of a little bit more automated, because you can run it and then you can parse your log statements, and then if something is in there, you can send an email or whatever. It's more flexible in this regard than Django Debug Toolbar. The pros and cons here are that pros is it works with Django and also SQL Alchemy in Flask. So this is great for all the Flask people out there. It probably also works with Fast API, but I tell you afterwards why I have not listed it here. Also, the pro is this thing with it outputs logs, because you can automate a thing and build stuff on top of it. So this I really like. And also the one pro is it doesn't work only on N+1 pros, but also the other way around. If you have a query that has too much related information in the query that is then afterwards never accessed, it will also tell you. So maybe you change your query to do not include everything under the sun, just to have a smaller, faster query. And the cons is it's also not in production. So at least the README says it. And I'm also like, I'm never sure for this not for production, if it is really not for production or the people are only a little bit scared that someone like a big corporation uses their project in production, something fails and they get sued by the lawyers. But yeah. Also, the big con here is that it is kind of dead. So the last release of N+1 was 5 years ago, I think, or 4. This is also the thing why FastAPI is not listed anywhere, because 5 years ago, I think FastAPI was not here yet. So maybe it's abandonware and yeah, it's not maintained anymore. And similar to Django debug toolbar, it is also a manual approach and not very proactive. So you have to go to your views to load them so that N+1 can do its thing and then put out the log messages. Here's also what I could think of doing is putting it on my staging environment where I have like production similar data than production has, and I have N+1 installed, and then I run locust load tests on my staging server every half an hour or something like this, and I parse my the log output and see if there are any problems in there. So with this, you could create some automated workflow where you just get an email when there's an N+1 problem in your project. And the last approach I want to mention is to detect N+1 problems directly in the database. This is an approach I did not do myself, but I want to mention it anyhow. So there are tools like PG Badger, that's a log analyzer for Postgres, which is just basically a tool you run where your database runs, and it consumes the logs that Postgres outputs, and it does analytics on that. Same is like PG Analyze, you install an agent near your database that, and also like you have to create a plugin in your database to collect stats, and then the agent collects the stats and sends it to some web service where you then have nice dashboards. Similar thing is also with Datadog, SolarWinds, AppDynamics. Those are these huge analytics platforms that have a ton of support for Postgres and other databases, and you can have really deep insights into your database, and also like how much memory and CPU is used, what queries are run, how often are queries run, and how long they take, stuff like this. They're really cool, but also like the pros and cons here. Like the pros is you do not need to touch your code. If your project is big enough, so you have like the app developers and the ops database persons, you can just let the ops persons set up these things, and the app developers will not notice it basically, and they will just build features. And yeah, this can be a pro and a con, because also like if you're not used to hosting your own database, or if you have like a cloud service where you run your Postgres, maybe it's not possible to run some of those tools inside or near your database. But also like the big ones I mentioned, they have integrations with all the big cloud providers, so you're covered there. But the main con is that those tools are made for analyzing single database queries and do not have the context. They do not know if like my website was run, there was one request in my website, and those are the 11 queries that belong to this one website rendering. So this is the thing that's missing. So it's hard to find the N+1 problems. You can see in those tools how often a query is executed. So with this, you could guess where the N+1 problems is. So as a summary, like how to detecting this N+1 problems is, first is that do nothing. It's like not the hardest or not a very strict problem. If your site works, just don't do anything. The second and the third is like using Django debug toolbar or N+1, where N+1 is a little bit, it's outdated basically, or not maintained anymore, but Django debug toolbar is still going strong. And the fourth thing would be analyze in your database with a database tool you maybe already have installed. So maybe the more of the senior engineers in here are like, come on, that's a beginner's mistake, right? It's like everyone knows N+1 problems. Everyone knows in Django to use preference related. Probably like that's like, it's just a beginner's mistake. But have a look at this website. Maybe some of you know this website. It's the documentation of the Django project. And it's like one of the best documentation websites I've ever seen. That's like, it's amazing. And a fun fact, they have, you can, somewhere is a link where you can download the PDF of this documentation. And the PDF has almost 2,800 pages. So it's like humongous documentation. And on this website, like, which has been here forever. And you can, down here, you can select the release, your Django release. So each page has different versions. It's basically, if you're using Django 2.0 or Django 4.0, the page has changed because Django has changed. And exactly with this thing here, they have an N+1 problem, because on each page load, like each running of one of all those pages on the documentation, they load this version picker down there. And this does around 11 SQL queries to fetch those versions. If you look at the code, it looks exactly like the examples we had in the beginning of this talk. We first select the document releases, the first arrow here, and then a couple of lines later, we want to access the release version, and the version is somewhere else in the database, so it does another query. And how did they fix it? Yeah, they just added a select related to it and done. Basically, they got rid of a lot of SQL queries to their database with this simple fix. But now the question is, yeah, but how did they like detect this N+1 problem? Because the website, djangoproject.com, or the docs website, has been here forever. It's like at least 15 years old, I guess, because Django is here since, yeah, since I was 24 or something like this. And what approach did they do to find this N+1 problem? And they choose the approach of doing nothing, because for them, it just, the site was working, everything was fine, they did nothing. But how did they discover it? Yeah, they did not, but Sentry did. And so I don't know if you know Sentry. Sentry is like, it's a tool that collects errors that you do not collect. So you install it in your production server, and then when there are some errors that are not caught by your code, Sentry will catch it, and you have then this list of errors. And normally you have stuff in there like type error, attribute error, module not found, whatever you have. And last month, we released a new feature that's called performance issues, where we try to detect N+1 queries. And the thing is, you need to have like the SQL integration or the Django integration of Sentry enabled. And then just out of like, since last month, this N+1 queries, you see down there, the blue error popped up in users' error lists. And also it's blue because it's not a soft, it's not a hard problem. It's not something that breaks your system. It's a nice to have kind of fix. When we released this, the Django project got a lot of new issues in their issue list, and they have set up alerts. So if there's a new issue, they will get notified via email. And we had a little bug on our end, so we created for each of those occurrences another issue. So they got 400 emails a day, I think, or something like this. That they were like, so hey, Sentry, nice that you have this feature now, but could you please not send us 400 emails a day? So we fixed it on our end. So that's also the nice thing about like being in contact with other open source projects and stuff. Yeah, so they were able to fix their problem. We fixed our problem with the implementation of this feature by the Django project's input. So this was really cool. And we also try to detect now not only N+1 queries, but more stuff. N+1 was the first, and now we are also detecting N+1 API calls. So it's the same thing, but the request doesn't go to the database; it goes to some REST service somewhere. We also detect slow DB queries. And the fourth one is like more for mobile apps, where you have like the main thread that uses to render the UI of your app. And if you have file IO on this main thread, it's not good. So we detect this too. And this is basically now, I want to ask you if you have any ideas of stuff we could try to detect, stuff like errors you always make, or like, every, I don't know, newbie to this framework does this error. You can always go to our GitHub page, GitHub get Sentry, to in the discussions there say, hey, try to detect this and this would be great. Yeah, and I think this is everything I have for you today. I think we can do questions and stuff. I don't know exactly how this works, but thank you very much for listening, if you made it this far.
Thank you so much. There is a little bit of a delay in LoudSwarm, but let's see if I don't see any questions in the Slack channel now, but what we can do is I will give everyone the link to face-to-face, and they can join you there to ask questions directly. So, Anton, this was a really great presentation. I know we have, some comments in the Slack channel already talking about all the issues with N+1. So
you're very nice, very nice. So I will I will just also hang out in the Slack channel the next hour or two, or I don't know.
Perfect.
Then,
okay, thank you so much.
Okay, thank you. Bye.